So, welcome to, we're going to be doing some practice. Welcome. We're going to be doing some practice with antiderivatives. So, as we get started today, just a reminder, if this is the first time you're seeing my face, please make sure it is not the last by hitting that like and subscribe button. We're going to be diving into just practice, practice, practice for antiderivatives. So practice makes progress. So the only way to get better at these is to keep working through them. Remember, the whole idea is that we use the power rule, maybe do a little algebra to simplify and see what we get here. So I'm going to rewrite this first one as x to the 1/3 plus 3 dx. So my antiderivative, I'm going to increase that power by 1. That'll make it 4/3. And I'm going to divide by the new power, which means there's a 4/3 down there. Plus the antiderivative of 3 is 3x. And don't forget your plus c, your constant of integration. Now, when we divide fractions, we flip the second one and multiply. So this becomes 3/4 x to the 4/3 plus 3x plus c. And we'll do the same for number 2 here. We don't need to rewrite it though. It's good to go. So we'll go ahead and increase that power by 1, put it over the new power. And we'll do the same, increase the power by 1, put it over the new power. Don't forget your constant of integration. And then, of course, we want to simplify. Now, for problem number 3, we're going to simplify first. So we're going to distribute that x squared. That gives me 2x to the 4th plus 3x cubed. And now we're ready to increase our power. Take the antiderivative. We'll increase the power by 1, put it over the new power, increase the power by 1, put it over the new power. Don't forget your plus c. I could leave it like that. If you want to write the fractions in front, you can do that. Okay, let's do the same for number 4. We don't need to rewrite it. So we'll increase the power by 1. Now 3 halves plus 1 would be 5 halves. So put that over the new power. And then increase your power here by 1, put it over the new power. And then the antiderivative of 1 is just x. Divide your fractions, you flip the bottom and multiply. So this becomes 2/5 x to the 5 halves plus x squared plus x plus c. Now for number 5, I would rewrite this. I would rewrite this as x to the 1/2. Be real careful in that second term, though. That is 1/2 x to the negative 1/2. You can't move the 2 to the top with the x there. So let's do the antiderivative. So we'll increase the power on x to the 1/2 to make that x to the 3 halves. Put that over the new power. And then we'll increase this power by 1, making it x to the 1/2, and then we'll put it over the new power. Notice how I wrote that 1/2 down there with the 2. I wrote it like that so we'll see that 2 times 1/2 will give us 1 there. Okay, let's flip this one. Gives me 2/3 x to the 3 halves plus, notice the 2 times 1/2 gives me 1. So this becomes x to the 1/2 and of course plus c. Now on problem number 6, I would encourage you to split this up into 3 fractions. So I would write 3x squared over x cubed minus 2x over x cubed plus 3 over x cubed. I would write it like this so you can see the simplifying and then rewrite it as 3x to the negative 1, although you might want to think about that x to the negative 1. We'll talk about it. And then I've got minus 2x to the negative 2, and then I've got plus 3x to the negative 3. So remember that you can use the power rule with any polynomial, except when x is to the negative 1 power. So in that case, I want you to think of this as 3 times 1 over x. and I'll keep the others. Now, the reason I do that is because the antiderivative of 1 over x is the ln of x. And more specifically, it's the ln of the absolute value of x. Now, the others you can do with the polynomial. So increase the power by 1 and put it over the new power. Increase the power by 1 and put it over the new power. So that gives me 3 ln of x. Now, minus 1, negative, that's going to give me a plus 2 over x. See, minus 3 over 2x to the second plus c. Lots of exponent work here. Gets a little tricky when you're doing it with negatives, so be careful. Now, this one I want to rewrite. When we multiply, we add exponents. So we're adding 3 plus a half. That gives me 7 halves. So my antiderivative becomes add 1 to the power, add 1 to 7 halves becomes 9 halves. And then you can flip and multiply. Okay. Same is true on number 8. I would rewrite that as, let's see, w to the first times w to the 1/2. That becomes w to the 3 halves. So then I want you to rewrite that as w to the negative 3 halves. So we'll increase the power by 1. So that becomes w to the negative 1/2 over negative 1/2. Think about negative 3 halves plus 1, negative 3 halves plus 2 over 2. And that's how I got that. So I've got, let's see, flip that and multiply gives me negative 2, and then bring this to the bottom, w to the 1/2. Keep practicing with your exponent rules. That's going to make these antiderivatives a little bit easier. Okay, let's rewrite number 9 here as 2 fractions. So I've got x to the third over x to the 1/2, and then I've got 3 over x to the 1/2. Go ahead, when you divide, you subtract exponents. So x to the third divided by x to the 1/2 becomes x to the 5 halves. And then I've got 3x to the negative 1/2. Now we're ready for antiderivative. Increase your power by 1 becomes x to the 7 halves over 7 halves. And then increase your power by 1 here becomes x to the 1/2 over 1/2 plus c. Now flip and multiply gives me 2/7 x to the 7 halves plus 6 x to the 1/2 plus c. Okay, now on number 10, this is a lot of multiplying. Okay, so I'm going to go ahead and multiply out that whole thing on the inside. Let's start with x minus 3 squared. That's going to give me x squared minus 6x plus 9. And then I'm going to multiply x plus 3 times that. So use your distributive property. That becomes x to the third minus 6x squared plus 9x plus 3x squared minus 18x plus 27. So this integral actually becomes x to the third minus 3x squared minus, that's a 9x plus 27. Now, friends, all of that work was meant to show you there's got to be an easier way than multiplying all that out. And there is, it's coming. But for now, we'll stay with this method. We're going to increase the power by 1, put it over the new power. Increase the power by 1, put it over the new power. Increase the power by 1, put it over the new power. And then finally, we've got 27x plus c. Let's do just a little bit of cleanup on that second term we have there. There we go. All right, now a few trig functions here. Number 11, we're going to first increase the power by 1. I keep saying that, but it is true. We put it over the new power. The antiderivative of cosine is positive sine of theta and plus c there. And then finally there on number 12, we're going to rewrite it as x to the 1/2 minus sine of x plus 2. So now my antiderivative is x to the 3/2 over 3/2. Antiderivative of sine is negative cosine, but there's already a negative there, so we're going to make that positive cosine. And then antiderivative of 2 is 2x plus c. Now remember, dividing means to flip and multiply, so this becomes 2/3 x to the 3/2 plus cosine of x plus 2x plus c. All right, now our last two here are what we call initial value problems because we've been given information to help us find that plus c. So if we have the derivative and we want to go back to the function, then we take the antiderivative. So we'll have the antiderivative, which will be the function. The antiderivative of 2x would be 2x to the second over 2. The antiderivative of sine would be negative cosine. There's a minus there, so that makes it positive cosine of x plus c. Now, we are being told that f of 0 is 4. So meaning I'm going to put 4 in for the function and I'll put in 0 for x. So I have 4 equals 0 squared plus cosine of 0 plus c. Now cosine of 0 is 1, so we can see that c is 3. Now remember, the problem didn't ask us for c, it asked us what was the function. So we come back to the step with the function here, and we plug in the value we found for c, and this is our answer. Now, we'll do the same for problem 14, but notice that we're starting with the second derivative. We have information on the derivative. Then we want to go back to the function. So we'll start with second derivative, and we'll go backwards. That'll give us the first derivative, which is x cubed over 3 plus c. Now we're told that f prime of 0 is 6, so that means that when x is 0, the derivative is 6. So that tells us that c is 6. So our first derivative is 1/3 x cubed plus 6. Now we want to know the function. So we've got to go one more step backwards. Do the antiderivative of this. We've got 1/3 x to the 4th, and we divide by 4, plus 6x plus c. Don't forget the antiderivative of 6 is 6x. And now we're told that when x is 0, the function is 3. So I've got 3 equals 1/12 x to the 4th plus 6 times 0 plus c. And I forgot to put a 0 in there, but you can see that'll also be a 0. So I end up that c for this one is 3. So my function would be 1/12 x to the 4th plus 6x plus 3. And I hope this helps your work, your practice with the antiderivative. Remember, the only way to get better is to continue to practice. So let me know in the comments below if there's another topic you'd like to see or you're not sure about one of the steps that I did here. I would love the opportunity to help. Bye-bye for now.